In this section, we continue our exploration into the realm of reconnaissance and enumeration, diving deeper into advanced techniques. We'll emphasize the importance of evolving your skill set to improve the effectiveness of your reconnaissance processes, particularly by focusing on script modification and tool utilization to adapt to different scenarios. Understanding reconnaissance and enumeration at an advanced level is vital for achieving the CompTIA PenTest Plus PT0-003 certification, and also for honing your practical skills. In this part of the course, we will cover key objectives and techniques that are crucial for an in-depth, thorough information gathering phase. On the upcoming slide, we'll explore how customizing scripts enhances your data collection capabilities. We'll discuss methods to make your scripts more robust and tailored to specific targets. As an example, we will delve into modifying a Python script to scrape web pages efficiently. Customizing and employing these scripts can significantly refine your approach to reconnaissance, making your findings more comprehensive and useful for subsequent phases of penetration testing. Now, let's move to our next slide, where we will see how to modify scripts for efficient information gathering. On this slide, we're delving into the significance of modifying scripts specifically for the purpose of information gathering. Customizing scripts is crucial for tailoring your reconnaissance and enumeration activities to suit specific contexts and objectives. First, let's talk about the importance of customizing scripts. By modifying scripts, you can enhance their efficiency and accuracy, ensuring that they deliver the precise information you need. This might involve tweaking certain parameters or adding new functionalities to accommodate unique environments or specific targets. Next, we'll cover some effective techniques for information gathering. These might include adjusting the script to focus on certain data points, integrating error handling mechanisms, or optimizing performance to handle larger data sets efficiently. For instance, let's look at an example involving a Python script to scrape web pages. Modifying a basic web scraping script allows you to selectively collect information pertinent to your reconnaissance goals. This could involve refining the script to target specific HTML elements or URLs, thereby narrowing down the vast amount of data on a web page to just the actionable insights. In summary, modifying scripts for information gathering not only improves the quality and relevance of the data collected, but also tailors the process to better fit your needs and objectives in a penetration testing scenario. On the next slide, we'll explore data manipulation techniques, covering tools and methods you can use to process and analyze the information you've gathered effectively. On the previous slide, we discussed the importance of customizing scripts for information gathering. We looked at techniques to enhance the efficiency of gathering data and provided an example of modifying a Python script to scrape web pages. Now we'll shift our focus to data manipulation techniques, which is a critical skill for processing and making sense of the data we gather. In this slide, we will provide an overview of data manipulation and delve into the tools and techniques that are commonly used to process data. One essential tool in Python for data manipulation is the Pandas library. Pandas offers powerful data structures and functions that make it easy to manipulate and analyze data sets. Here's a basic example of how you can use the Pandas library to process data. We start by importing the library and reading in a CSV file named data.csv. Python import pandas as pd-data, pd.readcsv, data.csv. Once the data is loaded, we may want to filter the dataset based on specific criteria. In this example, we are filtering the data to include only the rows where a certain column has a specific value. Python process data equals data column equals value. This simple yet powerful command allows us to extract a subset of the data that meets our requirements, which can then be used for further analysis or reporting. In the next slide, we will explore scripting languages, starting with Bash. We will cover the basics of Bash scripting, common commands and syntax, and how to automate tasks. As a practical example, we'll look at a Bash script that automates DNS enumeration. In the previous slide, we explored various data manipulation techniques with a focus on Python, specifically using the Pandas library to process data. We demonstrated how you can filter a dataset to retrieve rows that match a specific condition. Now in this slide, we'll shift our attention to Bash scripting. Bash is a powerful scripting language commonly used for automating tasks in Unix-based systems. We'll go through an overview of Bash scripting, touching on its syntax and some common commands. To illustrate, let's look at a sample script designed to automate a reconnaissance task, specifically DNS enumeration. The script reads a list of domains from a file named domains.txt, uses the dig command to perform DNS lookups, and appends the results to a file named dnsresults.txt. Bash tap bash script to automate DNS enumeration for domain in cat domains.txt. Do dig domain dnsresults.txt done. In this script, the for loop iterates through each domain listed in domains.txt. The dig command queries DNS information for each domain and appends the output to dnsresults.txt. Moving on to the next slide, we'll dive into Python scripting. We'll cover an overview of Python scripting, its common libraries and functions, and provide an example script demonstrating how to perform web scraping using the requests library and beautiful soup. On the previous slide, we explored Bash scripting, touching on its common commands and syntax, and diving into an example script for automating DNS enumeration. Now let's shift our focus to another extremely versatile scripting language, Python. Python scripting is known for its readability, ease of use, and extensive libraries, making it a favorite among developers and system administrators alike. In this segment, we'll cover an overview of Python scripting, discuss some commonly used libraries and functions, and walk through an example script to perform web scraping using the requests and beautiful soup libraries. Let's break down the example script. First, we import the requests library to handle HTTP requests and beautiful soup from the BS4 module to parse the HTML content. Python, import necessary libraries. Import requests from BS4, import beautiful soup. Define the URL we want to scrape. URL equals // example.com, send a GET request to the URL requests.get URL. Parse the HTML content of the response, soup's beautiful soup response.txt html.parser. Print the title of the web page, print soup.title. In this script, 1. We define the URL to scrape. 2. We send an HTTP GET request to this URL using requests.get. 3. We parse the returned HTML content with beautiful soup and specify html.parser as the parser. Finally, we extract and print the title of the page using soup.title. This simple example showcases how Python, combined with powerful libraries, can efficiently automate tasks such as web scraping with minimal code. Next, we'll delve into PowerShell scripting, another critical tool in the scripting landscape. We'll cover its common commands and syntax before illustrating its use through a practical script that gathers system information. Stay tuned. In the previous slide, we delved into the world of Python scripting, examining its common libraries and functions, with a focus on web scraping using the requests library and beautiful soup. We saw a straightforward example of fetching and parsing the title of a web page. Now, moving forward, let's dive into PowerShell scripting. Just like Python, PowerShell is a powerful scripting language, but it is particularly tailored for task automation and configuration management in the Windows environment. In this slide, we will cover the fundamentals of PowerShell scripting. We'll go over the common commands and syntax that are quintessential for any PowerShell script. To give you a glimpse into PowerShell's capabilities, we have an example script that gathers system information. Here, the command getComputerInfo is used to fetch comprehensive details about the system it's executed on. This command retrieves a wide range of information including OS details, hardware specifications, and much more. By understanding these basics, you'll be well equipped to start utilizing PowerShell for automating administrative tasks and managing system configurations. In the next slide, we will explore logic constructs with a focus on loops. We'll understand their significance in scripting, go through different types like for and while loops, and look at an example script in Python to see how loops can automate tasks efficiently. As we continue our exploration of scripting languages, let's delve into logic constructs, specifically loops, which are crucial in automating repetitive tasks in your scripts. On the previous slide, we discussed PowerShell scripting, focusing on common commands, and an example script to gather system information using the getComputerInfo command. Now, moving on to slide 7, let's examine the importance of loops in scripting. Loops allow us to execute a block of code multiple times, which is instrumental when handling repetitive tasks. There are various types of loops, including for and while loops. For instance, in a Python script, you can use a for loop to iterate a specific number of times. Here's a simple example. Python for I in range 10, print I. In this script, the for loop runs 10 times, printing numbers from 0 to 9 sequentially. This is a powerful way to handle tasks that require repetitive action without writing redundant code. Next, we will look at logic constructs related to conditionals on slide 8, where we'll discuss how if, else, and elif statements can help your scripts make decisions based on different conditions. Stay tuned as we further delve into how conditionals can enhance the decision-making capabilities of your scripts with a practical example. Slide 8. Logic constructs, conditionals. Now that we've discussed loops, let's move on to another fundamental logic construct in scripting, conditionals. Conditionals play a crucial role in decision-making within your scripts. They allow your code to execute certain sections based on whether specified conditions are met. In Python, the most common conditional statements you'll encounter are if, else, and elif. For example, consider this script where we're using conditionals to check if a user has administrative privileges. Python if user equals admin, print access granted, else, print access denied. In this script, if the variable user is equal to admin, the script prints access granted. If the condition is not met, it prints access denied. Conditionals are a powerful tool that can make your scripts more dynamic and flexible by allowing them to respond to different input and state conditions. In the next slide, we will delve into Boolean operators such as and, or, and not, which are essential for combining multiple conditions in your scripts. Now, let's move on to slide 9, where we delve into the role of Boolean operators in scripting. Boolean operators are essential in constructing logical statements that control the flow of a script. Boolean operators include and, or, and not. These operators allow us to create more complex conditions by combining multiple criteria. For example, using and requires both conditions to be true, or requires at least one of the conditions to be true, and not inverts the Boolean value of a condition. Let's look at an example script utilizing these Boolean operators. Python Boolean operator example, if user is admin and password were 1234, print access granted. In this script, access is granted only when both conditions, the user being admin and the password being 234, are met. This demonstrates how AND can be used to ensure multiple criteria are satisfied before proceeding with an action. Up next in slide 10, we will explore string operators. We'll cover the basics such as concatenation, substring, and length. Continuing from where we left off with Boolean operators, let's delve into another crucial aspect of logic constructs, string operators. On slide 10, we'll cover an overview of string operators that are essential for manipulating text data in Python. These include concatenation, substring extraction, and determining the length of strings. Here are some practical examples to clarify these concepts. 1. Concatenation. This is the process of joining two or more strings together. In Python, this can be done using the plus operator. For instance, Python full name equals first name plus last name, print full name. In this example, the first name and last name variables are combined with a space in between to produce the full name. 2. Substring. Extracting part of a string can be done using slicing. For example, if you have a string text equals hello world, you can extract hello using text05. 3. Length. You can determine the length of a string using the len function. For example, len full name will return the number of characters in the full name string. Understanding these operators enhances your ability to manipulate and utilize text data efficiently when scripting. Now, moving forward to the next slide, we will explore arithmetic operators. This will include an overview of addition, subtraction, multiplication, and division operators, and we'll see how to apply these in real-world calculations with Python. In the last slide, we explored various string operators, including concatenation, substring extraction, and calculating length with a practical Python example. We saw how to manipulate strings by combining first and last names and outputting the result. Now let's shift our focus to another critical aspect of logic constructs in Python: arithmetic operators. This slide provides an overview of the fundamental arithmetic operators you will frequently use: addition, subtraction, multiplication, and division. These operators are essential for performing mathematical calculations in your scripts. Here's a simple example to demonstrate an arithmetic operation in Python. Python arithmetic operator example, result equal 5 plus 3, print result. In this example, we are performing an addition operation where we add 5 and 3, storing the result in the variable result, and finally printing it. The expected output will be 8. Understanding these basic arithmetic operations will lay the groundwork for more complex calculations and logic in your Python code. Next, we'll dive into the importance of using libraries, functions, and classes for more sophisticated tasks, including an example of creating a Python class to handle reconnaissance activities. In the previous section, we discussed logic constructs with a focus on arithmetic operators such as addition, subtraction, multiplication, and division. We explored a practical example of performing basic arithmetic calculations using Python code. Moving forward, in this slide, we'll delve into the use of libraries, functions, and classes. Understanding the importance of these components is crucial for developing more sophisticated and modular code. To illustrate, let's consider the task of creating a Python class for reconnaissance purposes. Here I've created a simple recon class. This class has an init method that initializes the object with a target attribute and a method named gatherInfo that is intended to hold the logic for information gathering. Python class recon, def_init self_target, self.target, def_gatherInfo self, information gathering logic here pass recon equals recon example.com, recon.gatherInfo. In this example, our class can be easily extended with more functionality to perform various reconnaissance tasks. By structuring our code using classes, we make it scalable and maintainable, aligning with good software development practices. Next, we'll explore some of the essential tools used in reconnaissance and enumeration and discuss their significance in penetration testing. Continuing from our discussion on the use of libraries, functions, and classes in Python for reconnaissance, let's now shift our focus to some of the essential tools you can use for reconnaissance and enumeration in penetration testing. In this slide, we're going to cover an overview of these essential tools and discuss why they are so important in our penetration testing toolkit. Reconnaissance and enumeration are critical phases in the penetration testing process, as they help gather valuable information about a target system or network before launching any attacks. We'll look at key tools and their functions that cater to different aspects of reconnaissance, such as network scanning, service detection, and gathering metadata. Some of these tools include Nmap for network scanning, WHOIS for domain information, and tools like the Harvester for gathering emails, subdomains, IPs, and much more. Understanding how to effectively utilize these tools can provide you with a wealth of information needed to identify vulnerabilities and develop your attack strategy. By the end of this section, you should have a good grasp of the critical tools available and how each one contributes to thorough reconnaissance and enumeration. Next, we'll dive into the Wayback Machine, a powerful tool for retrieving historical data, and see how it can be leveraged in our reconnaissance activities to uncover previously exposed information or changes over time. Now moving on to slide 14, we focus on the Wayback Machine. This tool plays a critical role in reconnaissance by allowing us to retrieve historical web pages. Using the Wayback Machine can provide us with valuable insights into what a website looked like in the past, which can uncover information such as previous vulnerabilities, structural changes, and content that has since been removed. This historical data is indispensable during penetration testing as it helps paint a complete picture of the target. Here's a practical example. To retrieve historical pages of a site like example.com, we can use the Wayback Machine API with the following curl command: bash archive.org/wayback URL equals example.com. This command queries the Wayback Machine and returns available snapshots of the specified website, giving you access to its archived versions. Next, we'll delve into Maltego, which is another powerful tool for reconnaissance and data visualization. In the previous slide, we explored the capabilities of the Wayback Machine, focusing on how it can be leveraged for retrieving historical data, which is particularly useful during reconnaissance activities. We discussed using its API to retrieve historical web pages with a simple curl command. Now let's shift our attention to Maltego. Maltego is a robust tool for data visualization and relationship mapping. Its capabilities are incredibly valuable for building complex graphs that illustrate interconnected data points, which is particularly useful in mapping social connections and understanding the broader context of your data. In practice, you can run Maltego using the simple command maltego. Once executed, you'll have access to a wide array of functionalities that assist you in uncovering and visualizing hidden relationships within masses of data. Looking ahead, our next slide will introduce Reconnaissance, another critical tool in the reconnaissance phase. We'll delve into its modules and capabilities and go through some basic commands like Reconnaissance and modules search domain to get you started. Now, let's move on to discussing Reconnaissance, a powerful tool for reconnaissance operations. Reconnaissance provides a comprehensive environment for gathering open-source intelligence. Similar to a Metasploit framework for information gathering, it allows you to perform comprehensive recon operations. Some of the key capabilities of Reconnaissance include a wide array of modules designed to extract information from various sources, such as domains, IP addresses, and web technologies. This flexibility makes it invaluable for mapping out digital footprints and discovering potential vulnerabilities. Here's a look at a few basic commands to get you started. To start reconning, simply type reconnaissance in your terminal. To search for modules related to domains, use the command modules search domain. In terms of practical application, you can use Reconnaissance to gather data about a target by integrating it with multiple external APIs and databases. This versatility ensures you can aggregate extensive information, making your reconnaissance phase more thorough and efficient. In the next slide, we'll dive into Shodan, a search engine for discovering internet-connected devices, and explore its capabilities and basic commands. Continuing our exploration of popular OSINT, open-source intelligence tools, on this slide, we have Shodan. Shodan is often referred to as the search engine for the Internet of Things, IoT. Unlike traditional search engines that index web pages, Shodan indexes information about devices connected to the Internet. This includes everything from simple web servers to smart refrigerators. The capabilities of Shodan make it an invaluable tool for device enumeration and assessing the exposure of IoT devices. With Shodan, you can uncover various metadata about the devices, such as server types, open ports, and even default passwords, which helps in identifying potential vulnerabilities. Here's a basic example of how to use Shodan for searching devices. The command shodan search Apache. This conducts a search for devices running the Apache web server. You can refine your searches to look for specific versions, geographic locations, or device types, which can be highly beneficial when mapping the attack surface or assessing network security. In the next slide, we will delve into Spiderfoot, another powerful tool for automated OSINT. We'll take a look at its functionalities and a practical example of how to run a Spiderfoot scan. On this slide, we will discuss Spiderfoot, an essential tool in the realm of automated open-source intelligence, or OSINT. Spiderfoot is designed to automatically collect and analyze data from a variety of sources, making it a powerful asset for any security analyst or investigator. Spiderfoot's capabilities enable users to perform extensive reconnaissance by automating the gathering of publicly available information about a given target. This can include data mining for details such as IP addresses, domain affiliations, network infrastructure, and more. To illustrate Spiderfoot in action, let's consider an example command: bash spiderfoot example.com-o results.html. Here we are instructing Spiderfoot to scan the domain example.com and output the results into a file named results.html. This command showcases the simplicity and effectiveness of Spiderfoot in providing a comprehensive analysis with minimal effort. In the next slide, we will delve into WHOIS lookups, another crucial method for gathering domain information. On this slide, we're focusing on WHOIS lookups, a crucial tool in gathering domain information. WHOIS provides detailed information about domain ownership, registration dates, and contact details. This information is essential for anyone performing OSINT or investigating domain-related activities. For instance, you can perform a OIS lookup using the following command: oisexample.com. This command retrieves registration data for the specified domain, making it easier to understand who owns it and how long it has been around. In the next slide, we will delve into NSLOOKUP and DIG, two powerful tools for DNS queries. Stay tuned for detailed explanations and examples on how to use these commands effectively. Now that we've gone over WOIS lookups and how they provide essential information for domain information gathering, let's move on to our next powerful tools for DNS queries: NSLOOKUP and DIG. On this slide, we will delve into the functionalities of NSLOOKUP and DIG, two command line tools used for querying the domain name system DNS to obtain domain name or IP address mapping. Overview of NSLOOKUP and DIG. Both tools allow us to perform detailed DNS queries to understand the structure and behaviors of domains. DNS query capabilities. 1. NSLOOKUP. This utility allows for querying DNS to get domain or IP address information. It's often used for troubleshooting DNS issues and checking the records associated with a domain. Example command: NSLOOKUP example.com. In this command, NSLOOKUP queries the DNS to resolve the name example.com and returns the associated IP address and domain details. 2. DIG. DIG stands for Domain Information Groper. Similar to NSLOOKUP, it provides more detailed results and is often used for diagnosing DNS problems. Example command: dig example.com. This command sends a DNS query for example.com and returns a more comprehensive DNS response, including all the DNS records types like A, AAA, MX, NS, etc. Both of these tools are invaluable when assessing the DNS information of a domain. You can use them to validate DNS configurations, troubleshoot DNS issues, and gather information on DNS setups for both personal use and in professional environments. Next, we will explore Census.io, a tool known for its extensive capabilities in internet-wide scanning and gathering comprehensive data about devices and systems exposed to the internet. Stay tuned for an in-depth look at how Census.io operates and some example techniques you can employ. Continuing our exploration of tools for network reconnaissance, let's move on to Census.io. Census.io is a tool known for its advanced capabilities in internet-wide scanning. Unlike traditional scanning tools, Census.io can scan the entire internet to provide comprehensive data on internet-connected assets. With Census.io, you can analyze the state of the internet and identify trends in global security practices. It's particularly useful for discovering vulnerabilities, conducting broad assessments, and even tracking the deployment of new technologies. We'll cover specific techniques for utilizing Census.io effectively. For instance, how to query the database for information about specific ports or services, or how to filter results to focus on certain regions or IP ranges. In the next slide, we'll delve into Hunter.io, which is another powerful tool but focused on email enumeration. Let's proceed. On this slide, we're shifting our focus to Hunter.io. Just like Census.io assists with internet-wide scanning, Hunter.io is an incredibly powerful tool when it comes to email enumeration. First off, we'll cover an overview of what Hunter.io is and the core functionalities it offers. Hunter.io specializes in finding and verifying email addresses from various domains. This can be especially useful for penetration testers and cybersecurity professionals who need to map out an organization's potential points of contact for various reasons, including identifying potential phishing targets or simulating social engineering attacks. Next, we'll delve into its capabilities in email enumeration. Hunter.io can systematically generate email addresses using various techniques. For instance, it can find all emails associated with a particular domain, verify the validity of individual email addresses, and even detect specific email formats commonly used by a company. Finally, we'll look at some real-world example techniques. We'll demonstrate how to effectively utilize Hunter.io's search capabilities, filter results to narrow down the most relevant emails, and perform verifications to ensure accuracy. This hands-on approach will help you maximize the potential of Hunter.io in your security assessments. In our next slide, we'll transition to DNS Dumpster, another valuable tool, but this time for DNS enumeration. Stay tuned for how DNS Dumpster can aid in uncovering critical DNS information about your target. All right, now let's move on to DNS Dumpster, which is covered in slide 23. DNS Dumpster is a powerful tool that's widely used for DNS enumeration. DNS enumeration is an essential part of the reconnaissance phase in cybersecurity, where we gather information about potential attack vectors in a target's domain infrastructure. First, let's go through an overview of DNS Dumpster. This tool allows us to map out the footprint and infrastructure of a target domain by identifying DNS records, subdomains, and related information. It's particularly useful for pinpointing hidden assets that might not be immediately visible but can be critical entry points for further investigation or attacks. Now, discussing its capabilities in DNS enumeration, DNS Dumpster performs thorough scanning to uncover A, MX, TXT, NS records, subdomains, IP addresses associated with the domain, host names, and more. This comprehensive sweep helps in creating a clear picture of the target's network structure and can reveal potential weaknesses or misconfigurations. Some example techniques include using DNS Dumpster's web interface to perform manual searches or integrating its capabilities via API for automated reconnaissance tasks. You can export the gathered data into various formats for further analysis or documentation. In the next slide, we'll dive into Amass, another powerful tool focused on network mapping and enumeration. We'll discuss its features and show you how to get started with some basic commands. Moving on to Amass, detailed on this slide, we have another powerful tool for network mapping and DNS enumeration. Amass is widely known for its effectiveness in discovering subdomains and mapping out the attack surface of a domain. With its capabilities, you can conduct comprehensive network mapping and enumeration, identifying various assets connected to a target domain. One of the common techniques for running Amass is through its command line interface. For instance, to begin an enumeration process, you can use the following command: bash amass enum example.com. This command initiates an enumeration for the domain example.com, helping you uncover subdomains and other related assets. In the next slide, we will delve into Nmap, a robust network scanning tool. We'll explore its capabilities and see some example commands to get you started with basic and advanced network scans. Next, let's talk about another essential tool in our network reconnaissance toolkit, Nmap. On this slide, we'll cover the basics of Nmap. Nmap, or Network Mapper, is a powerful tool used for network scanning and host discovery. It allows us to identify live hosts on a network, discover open ports, determine services running on those ports, and more. One of the basic commands you can use to start with Nmap is nmap-sp 192.168./24. This command will perform a simple ping scan on the specified subnet. It's useful for identifying active devices within a network range. In the next slide, we will delve into the Nmap scripting engine, which enhances Nmap's capabilities by allowing us to run and customize scripts for more detailed scans and information. Let's dive deeper into the Nmap scripting engine, commonly referred to as NSE. The NSE significantly extends Nmap's capabilities by allowing users to write custom scripts tailored to their specific needs. These scripts can perform a variety of functions, including network discovery, more detailed version detection, and even vulnerability detection. With NSE, you can automate tedious tasks and achieve more comprehensive network scans. For example, you can use the HTTP enum script to enumerate various web applications hosted on a target machine. Here's an example command: nmap-script http enum 192.168.1.1. Running this command will execute the HTTP enum script against the IP address 192.168.1.1, providing you with more detailed information about the HTTP services running on that host. Next, we will explore another tool called the Harvester, which specializes in email, subdomain, and name enumeration to gather more detailed network information. On this slide, we're diving into the Harvester, a powerful tool for gathering information which can be crucial during the reconnaissance phase of a security assessment. The Harvester is a tool specifically designed for open source intelligence (OSINT) gathering. It excels in extracting valuable information such as email addresses, subdomains, and names from various public sources. This is particularly useful for gaining insights into the target organization by compiling data that could potentially reveal vulnerabilities or entry points. For example, running the Harvester with the command theharvester-dexample.com /b Google will search for data related to the domain example.com using Google as the search engine backend. This command will collect relevant information available in the indexes of the specified search engine. It's a straightforward and effective method to perform reconnaissance, laying the groundwork for further investigation or penetration testing activities. In the next slide, we'll explore wiggle.net, another valuable resource that focuses on mapping wireless networks. Continuing from our discussion on the harvester, let's move on to wiggle.net. Wiggle.net offers robust capabilities in wireless network mapping. It enables security professionals to gather data on the various wireless networks in an area, useful for both Wi-Fi reconnaissance and security assessments. By leveraging wiggle.net, you can identify the extent of wireless network coverage, detect potential security weaknesses, and better understand the wireless landscape of a given location. For example, techniques: you can upload your own Wi-Fi scanning data collected via mobile or other devices to map out all visible networks. Additionally, querying the existing dataset on wiggle.net allows you to see historical data on network changes over time. In the next section, we'll discuss Insider, another valuable tool for Wi-Fi network analysis. In the previous slide, we explored wiggle.net, an invaluable tool for wireless network mapping. We've gone over its capabilities and a few example techniques to leverage the platform for our tasks. Now let's move on to Insider. Insider is another powerful tool, but it focuses more on Wi-Fi network analysis. One of the key strengths of Insider is its ability to provide detailed insights into Wi-Fi networks, which is crucial for network troubleshooting and optimization. On this slide, we will give an overview of what Insider offers. We'll discuss its capabilities in Wi-Fi network analysis and illustrate how you can apply these capabilities in your workflows. By understanding how to utilize Insider effectively, you can gain a better grasp of your wireless environment, identify connectivity issues, and optimize your network's overall performance. In the next slide, we'll take a look at OSINTframework.com, a comprehensive resource for OSINT tools and techniques. Continuing on from where we discussed the capabilities of Insider in Wi-Fi network analysis, let's now shift our focus to another crucial resource, OSINTframework.com. As outlined on this slide, OSINTframework.com provides an extensive overview of various open-source intelligence, OSINT tools and techniques. These resources are invaluable for anyone involved in information gathering and cybersecurity. In particular, OSINTframework.com serves as a comprehensive directory that categorizes tools and resources into a well-structured framework, making it easier for you to locate and utilize the best tools for your specific needs. One of the main advantages of this platform is its ability to streamline the information collection process by directing you to the most efficient methods and resources available for OSINT activities. For example, suppose you're conducting a security assessment. In that case, you could use this framework to quickly find tools for social media analysis, geolocation tracking, or even deep web exploration. By leveraging OSINTframework.com, you can significantly enhance your information gathering strategies with minimal effort. Next, we will discuss Wireshark and TCP dump, which are fundamental tools for network traffic analysis. We'll cover their key capabilities and go through some example commands to help you capture and analyze network traffic effectively. Let's move on to the next slide. On the previous slide, we discussed OSINTframework.com, an invaluable resource for open-source intelligence tools and techniques. Now let's move on to analyzing network traffic, with a focus on two powerful tools, Wireshark and TCP dump. Wireshark and TCP dump are essential for anyone involved in network traffic analysis. They offer comprehensive capabilities to capture and examine network packets. TCP dump is a command line packet analyzer. Below is an example command to capture traffic on an interface, such as eth0, plain text TCP dump-i eth0. For a more graphical representation, Wireshark can be used. Simply launch Wireshark with the following command, plaintext Wireshark. Both tools enable you to dive deep into packet-level data, assisting in tasks such as network troubleshooting, security monitoring, and protocol analysis. In the next slide, we will delve into AirCrackNG, a suite of tools for assessing wireless network security. Similar to our approach here, we'll overview its capabilities and provide example commands for practical use. let's move forward. In our previous slide, we explored tools like Wireshark and TCP dump, which are incredibly useful for network traffic analysis. We went through some example commands to capture and analyze traffic, setting a foundation for understanding network communication in detail. Moving on to the current slide, let's delve into AirCrackNG, a powerful suite of tools for assessing wireless network security. AirCrackNG is widely used in penetration testing to evaluate the robustness of Wi-Fi networks against various attack vectors. One key capability of AirCrackNG is its ability to crack WEP and PAPSK keys using brute force or dictionary attacks. This makes it a crucial tool when testing the security of wireless networks. Here's an example command to get you started. Bash AirCrackNG-003 capture file.cap. In this command specifies the WPA2 protocol. -B denotes the target BSSD. Capturefile.cap is the file where the captured packets are stored. By running this command, AirCrackNG will attempt to crack the WPA2 key, illustrating the importance of strong, complex passwords for wireless networks. Up next, we'll be wrapping up with a conclusion and review of advanced reconnaissance and enumeration techniques. We'll summarize what we've learned and discuss the importance of these techniques in penetration testing and the steps you can take for further learning. So, in the previous slide, we dove into the details of AirCrackNG, exploring its capabilities in wireless network security, and walked through an example command to demonstrate its use. Now on this slide, we are going to wrap up everything we've covered in this module. In this course, we've delved into advanced reconnaissance and enumeration techniques, which are crucial for effective penetration testing. Understanding and mastering these techniques provide a solid foundation for identifying vulnerabilities and potential attack vectors within a network. It's important to remember that the reconnaissance phase is often the most critical part of a penetration test. A well-conducted reconnaissance and enumeration can set the stage for all subsequent phases of testing. As next steps, I encourage you to apply these techniques in a lab environment to gain hands-on experience. Consider diving deeper into other tools and methods that complement what you've learned here. Continuous learning and practice are key in the ever-evolving field of cybersecurity. Thank you for following along, and let's proceed to further learning opportunities and resources for enhancing your penetration testing skills.